let me back up. Chapter 5, you learned about like what an antiderivative was. Chapter 6, we're going to learn all the new techniques / shortcuts / like ways to do antiderivatives. So it's very similar to when you learned a derivative. You learned like what a derivative was, but then you learned the product rule, and you learned the quotient rule, and you learned the chain rule, and you learned all the rules that went with it. So this is the reverse. We learned what an antiderivative is, and now we're going to learn a bunch of new ways on how to do it, not just straight out memorizing ones. Like, you just memorize that cosine antiderivative is sine. Here, there's going to be strategies to figure out the ones that you can't just straight out memorize, okay? The strategy is called a U substitution, or a U sub for short. So we'll learn when it's helpful, when you can see it, and when it'll jump out. All right, so for example, before today, the only way you had to find the antiderivative of this was to first do the algebra superfoil. So you would need to take algebra and do a superfoil to it. And so it would become x minus 4 times another x minus 4 times another x minus 4, and then a dx. And you'd have to do a lot of algebra before your calculus could happen. So you'd end up with x cubed, and then you'd end up with minus 48x squared, and then you'd end up with plus 48x, and then you'd end up with minus 64, and then you'd have to do the antiderivative of each of those. So that was before. Today I'm going to show you a cleaner, slicker way to do that. Okay. So here's a different way. This is the way called using a U substitution. A U substitution says, take whatever is in the parentheses and replace it with the letter U. Okay, so in other words, we're going to take x minus 4 and we're going to replace it with the letter U. We also are going to need to replace dx with something as well. And so we figure that out by doing the derivatives on the red thing that we picked. All right, so let me ask you, what's the derivative of x? Okay, what's the derivative of 4? What's the derivative of u? Du dx. And if we want to do a replacement on dx, then we need to get dx alone in the red thing, the red work that I'm doing right now. In other words, 1 equals du dx. So how do you get dx alone in this situation? Yeah, I like to cross multiply. What would you drop under the 1? Another 1. I like to do that and then cross multiply, and that pretty easily gets me dx by itself. So in this problem, dx can be directly replaced with du. It's a straight replacement. Okay, so we're going to go back to our integral. We're going to place the yellow part that I circled with what? U. And we're going to replace the green part with just a du. Okay. All right, so what we end up with is u in parentheses cubed du. Much. So we're just doing this as a basic example. Then I can do the antiderivative of that. So we learned last chapter that the antiderivative of u cubed starts out as u to what power? U to the 4th. And then what do I do with the 4? Divide by 4. And what else do I remember? Plus c. Do I have any bounds this time? There's no bounds. Okay. And then your last step is to change u back to what you had originally picked u to be. So what is u representing? X minus 4. So we go back, and the antiderivative is x minus 4 to the 4th over 4 plus c. And that is the antiderivative. So I avoided having to superfoil out the work. So let me show you how this makes other problems a lot easier. Yeah?
How come you can't just look at the original and do the parentheses and do that by...
On this problem, you can, because what was picked in the middle of x minus 4 had a derivative of 1. Okay. And this one, I picked an easy one to start. Okay. In anything where the derivative is not 1, it doesn't work.
So it was like 2x minus 4?
Yeah, it doesn't work. Okay. Right. So, okay, so rule of thumb. if you see parentheses in the problem, U substitution is a really good idea. Train your brain. If you see parentheses, just associate that as I'm going to do a U sub. Even BC students who have known this now for a full calendar year, then they're working and I'm like, did you try? And they're like, oh, I can't do this antiderivative. And I just say, did you try a U sub? And they're like, oh, forgot, And then once they do the U sub, boom, it just works great for them. All right, so here's another one. Yes, we see parentheses. We're going to try a U sub. So the U sub is going to be to replace what is in that parentheses. So we take 5x minus 7. And we replace that with u. And then we just do the derivative. So the derivative of 5x, 5. The derivative of 7, 0. Don't need it. The derivative of u, du dx. And then cross multiply. So drop a 1 and cross multiply. That gets me 5 dx equals du. But dx is not yet by itself. So how do I get dx by itself? Divide by 5, or an alternate dividing by 5 would be multiplying by 1/5. Okay, so I look at my equation and I'm going to replace the yellow parentheses with u, and I'm going to replace the green with what I have dx by itself to be. So this is going to give me cosine parentheses u followed by 1/5 of du. So it wasn't a perfect like du dx match. It's now a 1/5 du. But we call 1/5 a constant. And what can you do with all constants in integrals? Pull them out to the front. So let's pull the 1/5 out to the front because it is a constant. And then I just have the cosine of u du. So the 1/5 still carries down as a constant, and the antiderivative of cosine, we learned, is sine of u plus c. And your final step, the derivative of cosine is negative sine, the antiderivative is positive sine, yep. And then the final step is to change the u back to the thing that it was representing in the first place. So we change it back to 5x minus 7 plus c, and I have my antiderivative. Okay, you with me so far? Yeah.
Can you just do antiderivative of sine? So cosine would be like sine 5x minus 7.
Mm-hmm.
Change divide by?
On this one, because it's a polynomial.
Yeah. So that doesn't work with
Right.
Oh, okay.
For example, that doesn't work on this one.
Okay.
Okay, now, I said when you see parentheses, do you see parentheses? You don't see them, but you can make them. All right, so let's make parentheses. And the parentheses would be, if I made them, 3x plus 2 to the negative 1/2, good, du. All right, so even if you don't see parentheses, make parentheses. Dx. And then, all right, well, those parentheses contain 3x plus 2. So I'm going to set 3x plus 2 as my u substitution. I'm going to take the derivative. That'll be 3 equals du dx. I'll cross multiply. And I'll use the fraction, so I end up with dx by itself being equal to 1/3 du. Are you okay if I skip the cross multiply step and go right to the fraction step?
No.
Nope. All right, so we'll go back, and in fact, I can do a couple things. I can pull the 1/3 out because I know it's going to get pulled out, and I'll have u to the negative 1/2 du. Anything we can do to simplify this problem. So then we're ready for an antiderivative. So that would be 1/3. The antiderivative becomes u to the positive 1/2. And then what do I have to remember to do with that positive 1/2? Divide by 1/2, which would be the same as multiplying by 2, and then add plus c, and then change it back. So I'll end up with the 1/3 and the 2 making a constant of 2/3. And then in the parentheses, I'll put back 3x plus 2 to the half plus c. How are we doing? Okay, so far? Sean, any questions? All right.
Can you leave it like that?
Yes, please. Yeah. I mean, you could put it as a square root if you want. The only thing you would not want to leave would be a negative power. Okay, you never want to leave a negative power.
Yeah.
But other than that, it would be okay if you left it. All right, here is rule of thumb number 2. So rule of thumb number 1, if you see parentheses, 99 times out of 100, U sub is going to be the best way. Rule number 2, if you don't see parentheses, but you do see multiplication, lots of times U substitution works great for that too. Okay, so if you see something times something else, maybe there aren't parentheses in it, but you see 2 things multiplied, then the U is one or the other of them. And I'll teach you how to choose which one is best. Now you can always just do trial and error. If one doesn't work, you try the other one. But I'll show you how to kind of pick which one's better than the other. All right, here we go. Now, rule of thumb number 1. Do you see parentheses? No, but you can make them. And rule of thumb number 2, is this a multiplication problem? Yes, so it's got both. Okay, so first is what you'd want to do is write the parentheses. So that would be 1 plus x squared to the 1/2 dx. And it's a multiplication. So you've got both. So what do you pick as your u? Still, if you've got that rule of thumb number 1 trumps rule of thumb number 2. If you've got parentheses, that's going to be your u. So we're going to choose this to be our u. Don't worry about the 6x hanging out there as a constant out in the or as a value out in the front. Don't worry about it. It will take care of itself. We're going to pick 1 plus x squared to be our u. And now this is the first time we've had this kind of derivative. What's the derivative on the 1 plus x squared side? Yeah, 0. I don't need the 0, but 2x. And then what's on the other side? Du dx. So this is the first time we've had something that still had a variable in it. Didn't have a constant, but it actually had a variable. But you still do the same thing. We're going to cross multiply. So I'll do the whole thing. So we end up with 2x dx equals du. I want the dx part to be alone. Either divide by 2x or multiply by 1 over 2x du. All right. Then I'm only replacing the dx. Don't worry about the 6x sitting there. I'll take care of that in just a minute. Yeah?
My guess is you always want to so you'd rather have 1 over 2x than du over 2x?
You know, it does not, no. We can do it, let's do a du over just to see how it looks. Du over 2x is going to work just fine as well. Let's try that. All right. Okay, so again, trust me, don't worry about the 6x right now. In your parentheses, you'll put your u. For the dx, what are you going to put? Du over 2x. So why did I tell you not to worry about the 6x? What? Yeah, how's it going to get taken care of? How's it going to be resolved? It's reduced. Why is it reduced? Because I have a 2x down here. That's going to take care of the 6x right here. And so when I reduce, what's the actual constant that gets pulled out? A 3. That will always happen if you haven't made a different math mistake somewhere else. If it doesn't happen, if you can't reduce, then that means that you should go back and check your cross multiplying or check something because you made a mistake somewhere. but it always should reduce. You should always be able to pull out a constant and then leaving you with nothing but u to the half du. That's all you're left with. So then your only work then is to do the antiderivative on u to the half, which u to the half becomes u to the 3/2 when you add, and then you're going to multiply by 2/3 as your coefficient out in the front. And then add c. And reduce again and be left with the number 2. And then replace your parentheses with the original choice. And then you have your final answer in simplified form. Okay, doing all right? Okay, you guys are stopping me and asking good questions. All right, here you go again. We've got both rules of thumb. We have a parentheses, and we have a product. But again, rule of thumb 1 trumps rule of thumb number 2. All right? Okay, so Nathan S., what are you going to pick for your u?
Probably sine 2x squared.
Sine is not in parentheses. Just the 2x squared. Pick the part that's in the parentheses. So you want 2x squared picked to be your u, and then you look at the derivative of each of those. So the derivative of 2x squared is 4x, and then we have du dx, which we work through our cross multiplication, and du, once you've isolated it, is, dx, once you've isolated it, is du over 4x. Or you could write 1 over 4x times du. So Nathan picked what was in parentheses, and I'm going to replace the dx at the end. I don't need to worry yet about the x, and I don't need to worry about the sign. I'm going to trust that those things are going to take care of themselves. So I end up with x times the sign, replace the yellow with the parentheses of u, and then replace dx with du over 4x. And then I can see that the reducing is going to happen. So these problems that you're going to have in your homework set tonight, they're designed to all work out perfectly. Okay, you shouldn't run into any wrinkles or bumps. If you do, again, that means you made a mistake and it's not the problem's fault. Okay, the farther we get in chapter 6, you'll have, anyway, all the problems tonight should work out. All right, so what coefficient will I pull out to the front? 1/4. The x's reduce away, leaving me with an integral that only has the sign of u, du in it, which has a perfectly easy antiderivative. So the antiderivative of sine is negative cosine of u plus c, and there's nothing else to reduce. So I can put my final answer with a negative and a 1/4 as the constant, and I can replace the u back with what it was representing, and that is the antiderivative. Incidentally, how do you check your work at the end? Like what I ended up getting, negative 1/4 cos 2x squared, how would I check that that was actually the right thing? Take the derivative. If I do take the derivative, should I end up back with? The thing I started with. Okay, if you ever want to check your work, you go backwards then. Take the derivative with the chain rule and check it again.
Yeah, it's probably right.
All right, rule of thumb number 3. U could be, if you recognize that one function is next to its own integral, next to its own derivative. For example, if you have sine next to cosine, right? If there are two multiplication things and there's no parentheses, but you have sine next to cosine, then you pick the one that has its derivative present there. So you'd pick sine, because sine's derivative is cosine. That's the rule of thumb number 3. So if you don't have parentheses, you don't have a multiplication, or you do have a multiplication but there's no parentheses, then pick the one whose derivative is actually there. So let me show you here. here's a multiplication problem. The multiplication is right in between these two things. But do you notice any part of this problem who has part of its derivative present? Or close to its derivative present?
X to the third.
X to the third, and what's x to the third's derivative? 3x squared. So what are we missing? The 3, but we've got the x squared part of it, okay? And so a constant, missing a constant is no big deal. We can, but we've got,
Forget the constant.
well, it'll resolve itself.
It's okay.
So when you're looking at that, this is what you want to pick for your u. Pick that one. Okay.
It's okay.
Don't worry about the x squared. It will take care of itself. Just worry about these two things. That's it, okay? Worry about, you're picking the x cubed because it has a higher power. And we know when we take the derivative of an x cubed, it turns into a square thing. So we're going to trust the process. So we're picking x cubed to be our u, which means 3x squared will be our du dx, which means cross-multiplying, dx by itself will be du over 3x squared. Trust the process. So go back and replace. Don't worry about the x squared. Don't worry about the e. Just replace the u as a substitution and then replace du over 3x squared. So if you trust the process, you'll always get to the part where something reduces. And you can pull out a constant. So what reduces here? The x squareds. And what constant can I pull out to the front? Not a 3, a 1/3. And that leaves me with e to the u du. So I'm now down to a super simple antiderivative, which is e to the u itself, divided by Lenny, which is 1, plus c. So Lenny is 1. So my answer will have the 1/3 coefficient out in the front, and then e gets replaced back with the u that it originally chose, and then I have plus c. Okay, just a couple more. They start out looking bad. Okay, they start out looking bad. Yeah. Yes, you know how to set your, okay. Okay, so rule of thumb number 1, can I write it with parentheses? Rule of thumb number 2, is there multiplication? Yes. Rule of thumb number 3, is one function next to its own derivative? We've got all of it. So we can write this in parentheses. So we can take cotangent x and put it to a 1/3 parentheses. We also have cosecant squared x dx. So we've got parentheses, we have multiplication, and we have cotangent next to its own derivative of cosecant squared. All we're missing is the negative. That's okay. All right, so Tyler, what would you pick as your u? Okay, so cotangent of x gets picked as my u. The derivative of cotangent x is negative cosecant squared of x. The derivative of u is du dx. So dx by itself has to be du divided by the negative cosecant squared of x. And if you're trusting the process, we're going to replace cotangent and we're going to replace dx, but we're not going to worry about the other pieces right now as we trust that it'll all work itself out. So we have u replaced to the 1/3. We still have the cosecant squared x there, but then when we replace our du, it's going to be over the negative cosecant squared of x. So I have something now that will reduce. That leaves me with a coefficient to pull to the front. So I'm going to reduce my cosecants and pull a negative out to the front. and all I'm left with is u to the 1/3 du. So then I'm ready for an antiderivative. So the negative antiderivative of u to the 1/3 is u to the 4/3, and I add 1 to that. And the fraction 3/4 out front. So my final answer would be the fraction negative 3/4 times the quantity cotangent of x raised to the 4/3 plus the constant of c. Okay. All right, last one. Sometimes a trig substitution, if nothing else works, you have no parentheses, you have no function next to its own, blah, 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 blah. Okay, a trig substitution might be helpful. In other words, what trig substitutions are we talking about? Change tan x into sine over cosine, or change cotangent into cosine over sine, or change cosecant into 1 over sine, or change secant into 1 over cosine. So those are a few things when I'm saying trig substitution that might be helpful. So I'll show you one of those and then we'll be done. So evaluate the integral of the cotangent of x dx. We've got no parentheses, we've got no multiplication, we've got no function that is present with itself. So we try a cosine of x over sine of x next to dx. Now, we don't necessarily have a one function that's derivative next to itself, but we have one that's under itself, which is still great. So we want to always pick your denominator. Okay, that's always going to be best. So go with if you've got those two things. So we're going to pick our denominator. So sine is what we're going to pick to be our u, because the derivative of sine is cosine. Which means cross multiplying gives me du divided by cosine. So the things I'm going to replace are my denominator and my dx. I'm not going to worry about the cosine right now. I'll trust that the process will take care of it. So I'm leaving my cosine in my numerator. My denominator changes to u. My dx gets replaced with du over cosine of x, which leaves me with something to reduce. When I reduce the cosines, I'm left with 1 over u times du. Does anybody remember, since you just took the chapter test on it, what's the antiderivative of 1 over u? Or it's a natural log. Not just the natural log of u, the natural log of the absolute value of u plus c. That is the only time you have a natural log. Only if you're in 1 over u du. That's the only natural. It's not 1 over u squared. That's not natural log. Only 1 over u, which then takes us back to the natural log of the absolute value of the sine of x plus c as our final answer. Yeah?
Would we be able to do the integral of absolute values using this, or no?
No.
Okay.